Unit 9, Day 3 notes. Today we're going to discuss finding the area of trapezoids, rhombi, and kites. Here are the formulas we're going to need for today. For trapezoid, it is area is equal to the base, first base plus the second base times height divided by 2. If you recall, the bases are the parallel sides, and the base and the height must be perpendicular just like it was on the triangle. And then we also need the area formula for the rhombus and the kite. Area is equal to diagonal 1 times diagonal 2 divided by 2. So on number 1, we have a trapezoid, and we're going to find the area. So let's write down the formula first. Area was equal to B1 plus B2 times height divided by 2. Well, it doesn't matter which one you call B1 or B2. Let's say this is B1, this is B2, and then this must be the height because it forms a 90-degree angle with both bases. So that means it's 13 plus 18 times 9, all that divided by 2. And then grab your handy dandy calculator, and I would type it all in one step. Save you some time. So in the calculator, we need to type in, turn it on first, alpha y equals, so I would put 13 plus 18 times 9 over 2. And then it's going to give you a fraction every time you do that. So then you could hit second answer and then math 2 to turn it to a decimal. So the area for this trapezoid is 139.5 inches squared. We have some units. Good. 135 point, was that what I said? 139.5, sorry. 139.5 inches squared. Again, area is always square. All right, on number 2, we have a kite. So the area formula for a kite was diagonal 1 times diagonal 2 divided by 2. So the first diagonal, they only show you part. They show you half of it is 8, so the other half is 8 as well, so that means it's 16. And then again, they show you part, so the other part is 2 as well, so the whole is 4. And divided by 2. So now we grab our calculator. And again, we can type it in at once. $16 times 4 over 2. And again, oh, they didn't give us a fraction this time. It's 32. So it's 32 units squared. Whenever they don't give you units, just say units. I'm sorry, number 2 is a rhombus, not a kite. Regardless, they have the same formula. Now, number 3 is a kite. And we know that the shorter diagonal is the one that's bisected. So if it's 5 here, there's 5 here. So again, it's D1 times and you should write the formula, and I want to see the formula every time. So I understand that you understand what you're doing. Plus, it'll help it convert to memory. So diagonal 1 is 10 because of the two 5s. The second diagonal, you have to take the 12 and add it with the 20, and you would get 32. And then divide it by 2. And now we grab our calculator. Times 32 over 2 is 160. So it's 160 units squared. On number 4, it tells us that a rhombus has a perimeter of 100 units. And the diagonal that measures 48, what is the length of the other diagonal? So we know from previous unit that the rhombus has 4 congruent sides. So if the total perimeter is 100, we can find each side by dividing it by 4, and we would get 25. And then it tells us about one diagonal being 48. It doesn't matter which one you choose. So let's say it's the longer one, just for kicks. And again, it's split into pieces. So that means half of it, 24, is up here, and the other half, 24, is down there. It wants us to find the other diagonal. So we're going to need to isolate the triangle and use Pythagorean's theorem. Doesn't matter what triangle you isolate, but it helps you to understand what's going on. So we have 24 here, we have 25 here. We're looking for this bottom piece, and that's going to be part of the diagonal. Then we're going to have to take that part times 2 in order to get the full diagonal. So let's, one step at a time, let's use Pythagorean's theorem. And we have A and we have C, so we're looking for B. So again, the shortcut to find B is take C squared, subtracting A squared, and put that in your calculator in one step. Square root 25 squared plus 24. I'm sorry, minus. Go back. 24 squared. And you get 7. So B is equal to 7. So in other words, this piece is 7. So that means this piece is also 7. So the diagonal is equal to 14 units. Number 5 is talking about the area of a trapezoid. It's 40 inches squared, and it tells us both bases. Our job is to find the height. So the area formula for a trapezoid, again, is B1 plus B2 times the height divided by 2. So now we're going to substitute the area now that we know what it is with 40. And we can replace the bases with 8 and 12. And again, we're looking for the height. Um, what I would do is put 40 over 1, so it looks like a proportion, cross multiply, so you would get 2 times 40, which is 80, is equal to 8 plus 12 times h. Then I would add 8 plus 12, you get 20. So it's 20 times h. And then I would divide both sides by 20 so that you get h by itself, which is what we're looking for, and you would get 4. So the height is 4 inches. And lastly, number 6 gives us the area of a kite, and it tells us one of the diagonals. We're finding the missing diagonal. So the formula for area of a kite is d1 times d2 divided by 2. And we're going to substitute a with the value that they told us for the area, which was 36. And it told us that one of the diagonals, so let's say it's d1, is 9. We don't know d2, and that's what we're looking for. So again, I would put 36 over 1 and cross multiply. So it'd be 2 times 36, which is 72. And that's equal to 9 times d2. And then divide both sides by 9, which would give you 8 is equal to diagonal 2, or 8 feet, since we know the units. And this concludes your notes for today.